So make a couple little notes here. This is a reflect in the x-axis. The A value would be a vertical stretch or shrink. Then we've got the function. So we have the start of the function. Inside of the function, I have a plus minus. And again, it won't be plus or minus. It'll just be like nothing or minus. But, you know, nothing means plus. So that would be a reflect in the y-axis, because that is a horizontal reflection. The B would be a translate. Nope, it's not a translate. Haha, just kidding. The B would be a horizontal stretch or shrink, depending on what the number is, if it's stretch or shrink. The H is a translate, and that could be a left or right, depending on what number is there. And then finally, the plus K is a translate up or down, because that one is outside of the function. One other thing you need to notice about this is that there is an extra set of parentheses. Right here, we have an extra set of parentheses. And that extra set of parentheses separates a reflection or stretch or shrink from the translation. So if you've got a negative sign under there, or if you've got a stretch or shrink, they cannot be in the same room with the translation. They will fight, so we have to separate them. We're going to kick them out, okay? So if we have both, something outside, like a plus, or no, plus won't show up. If we have a minus sign and or a number here, it has to be in its own factored out area, and the translation has to be separated from it. And we'll have examples like that, okay? This function notation, the function notation is used for every function we will do.
You still simplify it the same, right?
What do you mean by simplify?
So like, when you simplify the function.
Like if you're writing the function from words?
No.
No.
Like, so g of x equals, like, let's say 3x plus 6. And let's say the translation, or the stretch is 3.
What kind of stretch?
Horizontal. Yeah, horizontal. So it would be g of x equals 3, and then x plus 2.
I think, okay, so I'm on your right page, like what you're asking, but the way that you're saying it to me, it would not be x plus 2. What you were saying to me, it would end up being like this. But I'm on your same page. Yes, you would still simplify it, but that's if I gave you a function, then I said translate that function. We're not going to do that today, but yes, you would simplify it still, okay? So like this, if it was this, and you said it has a horizontal stretch of 3, I'd put in 1/3 x, and yes, I would rewrite this as x plus 6. Yes, I would do that. Today, I'm going to give you the equations, and you're going to graph them. So you need to be able to recognize that that 1/3 does what to the graph, okay? All right, so all we're doing today is finding functions and then using functions to graph, So the first example is finding some functions. If we can tell for sure that this vertex at 0, 0, nope, that's not 0, 0. That's not what I'm trying to say anyway. If it's at 0, -1, we've got our vertex. And then from there, the scale on it, the stretch on it is a stretch of 1. That means its next point would be like up 1 over 1. That's going to be a stretch of 1 because that's the normal parent function. If you can tell, then all we're really doing is looking at what happened with transformations or maybe reflections in question B. If you can't tell, I'll show you how to do it if you can't tell if there's a stretch or shrink. So question A, that would be f of x equals, and the only thing we have is it translated down 1 from where it normally would be at 0, 0. So we'd have our parent function x squared minus 1. Yes, dear.
How would you know if it was like a horizontal like stretch or a vertical stretch?
The only way you could tell would be if you saw the equation not simplified. Okay. With these, you can't tell. So that would just basically be either they're not going to give you one, or I will tell you there's a question in the assignment where, and I wrote this on Canvas, so if you're like looking at the assignment on Canvas rather than in the book, I wrote you a note saying this answer, there's actually infinitely many ways you could write this equation. It's number 16 in the book. Infinitely many ways you could write the equation. So what I did instead is I gave you a multiple choice and I said, which one of these would actually do it? So you can look at the parent function and look at my answers and figure out which one it is and then write the equation from there. Because there are some where you look at it and you don't know for sure what was done. So you could have, all of you could have the same correct answer, but they would all be different answers, some of them. That was a long explanation. Basically, you can't tell unless you have the equation, okay? But for these, I don't think we have a lot. You know, typically, I will say typically with a parabola, we tend to use a vertical stretch or shrink over a horizontal because you guys know if I have y equals 3x squared, I can multiply that out. And I could have y equals 9x squared. So here's a vertical shrink of 1/3. Nope, I said vertical. Horizontal shrink of 1/3. And here is a vertical stretch. Factor of 9. But they're literally the exact same graph. So if all you have is the graph, both of these answers would be fine. Typically, with parabolas or lines, absolute value, maybe, we typically like to use the vertical, not the horizontal. It's just easier. When you have square roots, that one, usually it's outside of the square root or inside the square root because that's harder to simplify. So it kind of depends on the function too. All right, going back to B, I'm looking here. One thing that we should definitely notice is that it has a reflection. It's facing down. So f of x equals negative. And then we've got to translate to the left 1. So we write that opposite, plus 1 squared, and then up 1 plus 1. This is a question I copied from the book. So your assignment will have questions just like this, only they won't be this one because I took this one out of the book. It'll be the other ones around it. Question C is a little bit harder to tell. So I'll definitely find my vertex at 2, 6. And I know it's going to be a negative in front. So I know for sure the negative out front. I know for sure the -2 in the inside. I know for sure that it's squared, and I know for sure it's a +6. But I don't know if there's a stretch. So if you're not sure if there's a stretch and you can find another ordered pair, we can plug that -2 or 0, I don't know why I'm talking, 0, 2 in for x and y and solve for a. And so I get a is 1. So we can plug in the ordered pair to see if there is a stretch in front, which this tells me a is 1, so it didn't have a stretch. But if there was a stretch, I would find the a value at that point. So my equation for this one is just f of x equals negative x minus 2 squared plus 6, because there's no stretch. Okay. And then the last one looks like we've got 5, -3. The x-intercepts don't look like points that I could actually find. It does look like we've got 4, -2 and 6, -2, which would be an up 1 over 1. So I'm going to assume my a value is 1. Probably not good to assume, but it is for this one. And then we just need our -5, -3 in there. Questions on this guy? So if you don't feel confident about one of these, type it in Canvas, hit check right away. Don't type all of it in and then check. Like if you're doing your assignment, you're like, I don't know about this one. Just check it right then. Okay. And then you guys are, a lot of you doing good jobs about like, hey, Miss Criswell, I don't know what I'm doing wrong on number 5. I keep missing it. And then I will send you messages back. Rarely I say we have to meet in person because I can't tell what you're doing wrong either, but usually I'm able to figure it out. Okay. All right. Example 2, the rest of the examples are graphing. So I'm going to plow through this. I'm going to use transformation tables. I will not be plugging in x's and finding y's. I will be using the parent function and then transforming it. So the first thing I do is look and see my parent function is x squared. So I'm going to use my points for x squared that I like to plug in and what they become after I square them. So the parent function itself is not the answer, but it's going to help me with my transformations. One thing that's helpful about the parent function itself is I have the vertex right in the middle. And then on either side of the vertex, we have symmetrical points. So it's going to save me some time when I graph it because I already know where the vertex is, which is really one of the main things that I care about quadratics, is that part where it changes from increasing to decreasing or vice versa. And then on either side is symmetrical, so that's going to save me some time when I graph it. Then we're going to write our transformations. We've got a 2. And then we have a -4. Neither of those are being squared, so that's all vertical transformations. The 2 is going to be a vertical stretch by a factor of 2. And this is what we were doing last week, only we were only doing it with words, not doing the graphs. And then we translate down 4 units. Both of these are vertical, so both transformations are going to affect my y values. Vertical stretch by a factor of 2 means multiply by 2, That's what that means. Translation down 4 is subtract 4. By order of operations, what do you have to do first? Multiply or subtract? So in my table, I will always do multiply before I do add or subtract. So I was able to fill out my y side because I only had to think of the first 4 values and the other 4 are symmetrical. And then there's nothing on the x side. So the ordered pairs that I will graph will be my x's and my most recent y's, the ones that are on the outside of my transformation table. 14 is not going to fit on the graph, so I'm not going to graph that one. Oopsies. So you can see it is a vertical stretch because it's rising up faster. It's also pushed down 4 units. Then you guys, domain and range, we've been going over that a lot. The domain for this particular function goes all the way to the left, all the way to the right. So negative infinity, positive infinity. The range, it goes down to -4. It does equal -4. Then it goes up to positive infinity. Questions? I'm going fast because I want to make sure I get through all the examples, but I am recording a video. So if you needed to go look at one of those examples that I went too fast on, it will be there for you. Okay. But you can also ask while I'm doing it because I can't tell what you guys have questions on if you don't ask. Okay, example B has something special going on. Example B has negative parenthesis 2x plus 6 close parenthesis squared minus 1. You have that in front of you because I'm going to go somewhere else, but I want you to have that equation in front of you. Do you have that equation in front of you right now? Okay, so I'm going to go somewhere else on my computer, not my computer, on my notes. And if we have a 2x plus 6, we're going to have a problem. Because when you have a 2 inside of the function and like a plus 6, they cannot be in the same parentheses together. They can't be in the same room. They're going to fight. You got to separate them. Okay? So right here, to get them out, to get them separated, we are going to factor mailbox. So we're going to factor the 2 out from the 6. You're welcome. So I'm going to rewrite this as h of x equals. Now, it's still a horizontal transformation, so it does not come out of the parenthesis. It doesn't come out of the squared. So we have 2, and then I add in a second set of parentheses, x plus 3, close parenthesis squared, minus 1. So now it's separated. And I hope you can see if you don't factor, you're totally going to get the wrong translation. You'll get a 6 instead of a 3. So we got to make sure that if there's something in that location and a translation, we've got to factor it out first. Okay. I'm going to quickly write my, it's a squared again. So I'm going to quickly write my parent function points. And plot my parabola. Okay, transformations. We have a negative sign, so that is a reflect in the x-axis. Then we have a 2. That is on the inside. So that is a horizontal. And then it's either a stretch or a shrink. So I'm going to leave a space for a second. Horizontal something by a factor of something. So sometimes when my brain is not working at 100%, I can't think if it's a stretch or a shrink. So I have to figure out, well, what would I actually multiply by? So remember, horizontal, everything's opposite. If there's a 2 being multiplied on the inside, if there's a 2 being multiplied, that means I have to divide by 2, which is the same thing as multiplying by 1/2. So that's what my factor is going to be. So is that a shrink or a stretch? That is a shrink. Half of something makes it smaller. So sometimes thinking about the factor first. 2, you really want to say stretch, but it's not. It's a half. Then what do we have? We have a translate. 3 units, and that's positive, so it's going to go left. And 1 unit down. So when I fill out my table, I always have to multiply before I add or subtract. So my y side is going to be multiply by -1 and then subtract 1. My x side is going to be multiply by 1/2 and then subtract 3. So I don't know. You can start on either side. I'm starting on my y side just out of habit. My x side, so my y side's symmetrical around the vertex. My x side goes up by the same amount each time. So when I go and I start multiplying these, they're going to go up by the same amount each time. So this will be -3/2. This will be -1, -1/2, 0, 1, 3/2. And then I'm going to subtract 3 from each of those, which is the same thing as subtracting 6/2. And again, I know I'm going fast, but you guys can always refer to this later if you need it, or maybe you don't need every single thing that I wrote down. So now I'm going to graph -9/2, which is -4.5, -10. I'm going to zoom out a little bit. As I'm graphing, my vertex was 0, 0, is now -3, -1. So anything on the other side of this vertex is going to be reflecting. So that could definitely save me some effort. -4, -5, -3.5, -2. So once I get to the other side, I can just reflect them. And then my domain is everything. So -infinity, +infinity. And the range is going to begin at -infinity and end at -1, including -1. Are we keeping up or not? Decently? Okay, so my next one, we now have a different parent function. We have a square root of x. So my parent function points are going to be things I can square root. Oops. Transformations, I know that there is a vertical stretch by factor of 3. So on my vertical side, I will multiply by 3. And then I go underneath the square root. And what kind of crazy nonsense is happening under the square root? What's happening under the square root? Maybe a different question. What do I need to do? Patrick? Oh, is that him who's done it?
Yeah, that's how.
Is that what you were going to say too? Okay. Go ahead, Patrick.
Well, you just try to get it times everything by 2 to try to get it all to.
So we cannot have a negative half x and a minus 2 in the same group. You can't see the parentheses, but they're both under the radical together. We need to separate them by using factoring. So we are going to factor out a negative half. And Patrick said, well, you could just like multiply by 2. I'm actually going to multiply by negative 2, but yes. So I'll have that 3 square root. I'll have negative a half, an extra parenthesis x plus 4. So I factored out that negative a half. It changed the sign to positive. It changed the 2 into a 4. So now we have a horizontal. Nope, I'm not going to start with that. Then we have a reflection in the y-axis, because that's the negative sign. Horizontal. So is a half going to be a stretch or a shrink when I reciprocate it? Right, this is going to be a horizontal stretch by a factor of 2. So that's what I'm going to multiply by. Actually, multiply by negative 2 because both negative and 2. And then we'll have a translate to the left 4 units. So after I multiply by negative 2, then I will subtract 4 for my x's. So after I do the operations on my transformation table, I get negative 4, 0, negative 6, 3, negative 12's off the graph, 6, and then, okay, I'm not going to go graph the last one. Whoop, that was ugly. Domain is going to go from negative infinity to negative 4, and it includes negative 4. So that's the x values from left to right. The range, how low to how high, it's going to start at 0, and then it's going to keep going up to infinity. Questions? Real fast before we do the last example, can you thumbs up, thumbs medium, thumbs down about how confident you feel in this stuff from remembering things from before? I want to see thumbs. I didn't see it. You can stop with the thumbs. All right, the last one. We've got absolute value as our parent function. So I will just use negative 2, negative 1, 0, 1, 2. and then I will absolute value that and get all positive. And I will plot those points and get a V for value, absolute. Transformations, we've got a vertical. Is that going to be stretch or shrink? Shrink by a factor of 1/2. Remember, by a factor of means I'm going to multiply by 1/2. Then we have a horizontal, and it's either a stretch or a shrink by a factor of, so if I see a 4 there, it's going to be a 1/4. If you write down a 1/4, if we are multiplying by 1/4, is that going to be a stretch or a shrink? If it makes it smaller, it is a shrink. And then translate, oh my gosh, 2 units down. So that'll go on the Y side. Okay, what ends up happening here is I've got awful tiny, oops, that's supposed to be 4. Teeny tiny little fractions here. And when I graph those, I can't really even see much of what's going on, like -1/2, 1, -1/4, 1/2, like really? I mean, this is what I'm left with. You guys can't even see it. So it is okay to add some more numbers in. What would be a good number to add in there? 4. What's another one? 8. Give me one more. Sure, I was actually thinking 12, but 16 works too. You could do 16 also. Oh, you can't. I'm not saying there's like a right or wrong. Okay, so then if you're multiplying by 1/4, then we get some nice, easier answers. And then on the other side, multiplying by 1/2, I get some nice, easy answers. But when I graph those, I only did the positives, but with absolute value, you know, they're symmetric. So once I find the positives, I'll get some other points too. So 1, 2, 2, 4, 3, 6. And then I can find the symmetric values. And that's going to be like a lot easier. So just because I did all of my tables one way doesn't mean you can't add on extra points. You definitely can add on extra points to make it a graph that you can see. Oh, I forgot something. That's not it. What'd I forget? I forgot to go down by 2. Oopsies. So my vertex, when I go down by 2, I'm going to be at 0, 2. And then I know for sure, like I've got this point here at 1, 2, and then go down by 2 is 1, 0, 2, 2, 3, 4. Did I do that right? Yeah. 3, 4. And look, I didn't even go back and graph those. I didn't even go back and graph the fractions because I already found nice answers that I don't have to graph those fractions. So domain is going to be all real numbers. So -infinity to positive infinity. And then the range goes down to -2, goes all the way up to positive infinity. Okay, so I just made a long video, but in a very short amount of time. So it will be posted for you if you need to go back and look at anything, but you can also just send me questions if you have them.